Another interesting physics question. Please endeavor to watch this video to the end. You will love it. This is what the question represents. I've just put down the picture or a figure interpreting the question. The question says there is a rough surface. So you can see the rough surface, and a 10 kg block is placed on the rough surface that is pushed by a force of 100 Newton. A horizontal force of 100 Newton is pulling the 10 kilogram block along the rough horizontal surface. Because the object is moving, it has a kinetic friction. It has a coefficient of kinetic friction. That coefficient of kinetic friction, mu, is given as 0.3. That is the coefficient of friction that exists between the rough surface and the block as it moves along the surface. Now, there are several forces acting on this object because our target in this question is to find the acceleration of the block. The block is moving, so it was accelerating, and we are to find that acceleration. However, we need to understand that there are several forces acting on this object. Let's identify the forces one after the other. The first one we want to identify is the weight of the block. Weight always acts vertically downward. So the block has a weight that acts downward. Now, remember that according to Newton's third law of motion, to every action, there is an equal and opposite reaction. Now, because the weight is acting downward, the surface must react to that weight by acting in the opposite direction. So we can call that R, the reaction to the weight. Now, the last force we are going to put into this figure is the frictional force. The object is moving to the right as a result of a force of 100 Newton, but there is an opposing force acting on the object. That force is the frictional force, and because it is opposing this force, it must be acting to the left. We call it the frictional force. So these are the forces that are acting on this object. If the question has asked you to draw the force diagram, you can simply draw these four forces coming from a point and omit every other thing. That is sufficient. Just draw R, W, F, and FR. But that is not what we are after. We are after the acceleration of the block. Now that we know the forces acting on the object, let us now solve the problem. We are told that the object is accelerating. For an object to accelerate, it means there is a net force acting on that object. That net force is the difference between the applied force and the frictional force. So we say that F net will be equal to the force moving to the right minus the frictional force to the left. That means overall the object is moving to the right. That is why it has a coefficient of kinetic friction and also an acceleration. Now we know F, but we don't know Fr. What is Fr? Frictional force is defined mathematically as the product of the coefficient of the friction times the reaction. Fr equals to mu r. What is R? R is an equal and opposite force to W, which is the weight. What it means is that the weight acts downward, R acts in opposite direction, and they are equal. So R is equal to the weight, and the formula for weight is mass times acceleration due to gravity g. So we can replace R with mg, so that this formula becomes Fr equals to mu mg. Now it's getting interesting. Let's plug in values. Fr will now be equal to 0.3 for mu times 10, the mass, times 10, what we are taking as acceleration due to gravity for this question, approximately 10 meters per second square. Multiply these values and you're going to get 30 Newton. So the opposing frictional force is 30 Newton. The net force, therefore, will be 100 minus 30 because it is the difference, and that is 70 Newton. Now remember, for an object acted upon by a net force, that object must be accelerating. And the formula for a net force, or for force generally, is given as mass times acceleration. So from here we can make A subject of the formula by dividing both sides by m, which gives us F net divided by m. Simply plug in the values. F net is 70, mass is 10. 70 divided by 10 will give you 7. So the acceleration acting on the block is 7 meters per second squared. That is the answer to the question. You can see how simple it is and straightforward. I know you enjoyed this video. If you did, please like it, share it to your learning colleagues and friends, and drop your comments in the comment section because I'm always there waiting for you. Follow our page if you have not done so, and if you are watching this video on YouTube, consider subscribing. Thank you very much for watching this video, and I hope to see you in our next video.